Look at your hand. Close your eyes for a second and feel the weight of your own palm. Feel the texture of your skin, the solid resistance of the chair beneath you, the cool air moving against your face. For your entire life, your brain has told you a very specific story about these sensations. It tells you that you are a solid object moving through a world made of other solid objects. It tells you that if you could zoom in far enough, past the cells, past the molecules, you would eventually find the bricks. You'd find the little marbles of reality, the atoms, neatly stacked like the most complex Lego set in the universe. This is the lie of the marble, and it is the first thing we have to dismantle if we want to understand what is actually happening at the foundation of our existence. The tragedy of how we teach science is that we give you a map and tell you it's the territory. We show you a colorful diagram in a textbook, a dense cluster of red and blue grapes in the center, representing the nucleus, with little balls zipping around it in perfect concentric circles like a miniature solar system. It's friendly, it's intuitive, it makes sense to a mind evolved to track predators and gather fruit. We've been told for generations that this is the fundamental unit of matter, a tiny machine of parts sitting in space. But as you're about to discover, that image isn't just a simplification, it is a fundamental deception. It's a 3D shadow cast by a ghost that doesn't even live in our three-dimensional world. Think about the scale of this deception. Atoms are ridiculously and unbelievably small. A single human hair is about as thick as 500,000 carbon atoms stacked on top of each other. If you look at your fist, it contains trillions upon trillions of these structures. To try and visualize them, imagine if just one of those atoms in your hand were inflated to the size of a marble. If that happened, your fist would suddenly swell until it was the size of the entire Earth. Now imagine you are standing in the center of that Earth-sized fist, looking for the stuff that makes you, you. You look toward the center, and miles away, you see a tiny speck. That's the nucleus. It's the size of a single grain of dust, sitting in the middle of a vast empty stadium. Everything else, everything between that grain of dust and the outer edge of the atom, it's empty. Except it isn't. What we perceive as emptiness is actually a boiling, frantic sea of quantum fluctuations. These are fields that have potential energy, building and dissolving spontaneously. This emptiness is what gives you your shape. When you press your hand against a table, you aren't feeling two solid things touching. You're feeling the electromagnetic repulsion of two ghosts refusing to occupy the same space. You have never truly touched anything in your entire life. You are levitating on a cushion of invisible forces, a fraction of a millimeter above a world that is essentially a void. If you were to subtract all the space between the nuclei from the Empire State Building, the entire structure would be about as big as a grain of rice. All the atoms of humanity would fit inside a single teaspoon. For over 2,000 years, we followed the dream of a man named Democritus. He stood on a beach in ancient Greece and wondered if you could just keep cutting a grain of sand forever. He decided there had to be a limit, the atomos, the uncuttable unit. Later, John Dalton drew beautiful circles representing these identical units, helping scientists make accurate predictions about chemistry. We spent 2 millennia trying to find those bits, convinced that reality was built of individual, indestructible parts. And then, just as we reached out to grab them, they vanished. In modern physics, the atom is not a miniature machine made of parts sitting in space. It is a mathematical object, a probabilistic structure. We talk about the electron as if it's a particle somewhere in that void, or perhaps a fuzzy cloud of probability. This cloud, or orbital, represents where the electron might be with a 95% certainty. But even this is a lie of perspective. The math tells us that the probability of an electron being in one spot never actually hits zero. It gets smaller and smaller as you move away from the nucleus, but it never stops. This means that, in theory, the electrons of the atoms in your heart could be on the other side of the universe. You are not a localized object, you are a localized peak in a field that stretches to the ends of the cosmos. But here is where the story gets truly strange, the part that typical documentaries usually skip because the visualization starts to fail. We are used to thinking of the atom as a 3D object because we live in a 3D world. But for multi-electron atoms, the wave function cannot be visualized in ordinary space at all. It exists in a high-dimensional mathematical space called configuration space. In this realm, each particle adds more dimensions to the map. An iron atom isn't a 3D object, it is a pattern vibrating in a space with over 100 dimensions. When you look at a picture of an atom, you aren't looking at the atom itself. You are looking at a 3D slice of a higher dimensional ghost. You are seeing the shadow of a structure that our brains are biologically incapable of visualizing. This brings us to a radical realization. The atom might not even exist as an individual thing. Some of the most profound theories in physics suggest that there is only one wave function describing the entire universe. In this view, individual atoms are just temporary patterns or ripples within a single universal structure. We call them building blocks because it helps us build bridges in medicine, but they are more like the crests of waves in a single infinite ocean. We are not a collection of Lego bricks. We are a specific, temporary vibration in the same fabric that makes up the stars and the void. The atom is not a thing we found. It is the boundary where our language and our intuition fail. To understand the atom is to realize that the world we touch is a three-dimensional shadow of a high-dimensional probabilistic mystery. We have lived our lives believing in the marble. We believed in the solid, the discrete, and the local. But the deeper we go, the more the reality of the atom reveals a universe that is not made of stuff, but of information and probability. The solid world you feel around you is an illusion created by the frantic, flickering motion of these high-dimensional patterns. We have finally reached the point where we can see these structures with scanning tunneling microscopes, feeling the surface of atoms like a hand moving in the dark. But what we are feeling isn't a solid ball. It is the resistance of a field. It is the edge of a question that physics is still trying to answer. As we move forward, we have to leave behind the solar systems and the billiard balls of our childhood. We have to prepare ourselves for a reality that doesn't just challenge our common sense, but actively defies it. Because once you realize what an atom actually is, you realize that you have never truly seen the world. You've only been looking at the surface of a high-dimensional ocean, mistaking the ripples for the water. The deeper lore of the atom suggests that we are living in a glitch of perception, and the real story of our existence is hidden in the spaces between what we think we know. The atom is not a thing, it is a question. And the answer to that question will change everything you thought you knew about being alive. To understand where the lie began, we have to travel back to a beach in ancient Greece, nearly 2,500 years ago. Imagine a man named Democritus standing by the surf, holding a single grain of sand between his thumb and forefinger. He's asking a question that seems simple, but is actually the most dangerous question in the history of thought. If I take this grain of sand and cut it in half, then half again, and again, can I keep going forever? Is the universe a smooth, infinite smear, or does it eventually hit a wall? Democritus decided there had to be a wall. He argued that at some point you would reach a particle so small and so indestructible that it could not be divided further. He called these particles atomos, a Greek word that literally means uncuttable. He imagined them as solid, eternal things, tiny billiard balls with hooks and eyes that latched together to form the world. Halfway across the world in ancient India, a sage named Maharishi Kanada had a similar epiphany while eating. He realized that as he chewed his food, it became smaller and smaller until it reached a point of invisibility. He called this Anu. For these ancient thinkers, the atom was the ultimate thing, the final solid floor of reality. This idea, this Democritus delusion, stayed with us for 2 millennia. It was the comfort of the brick. We wanted to believe that the world was made of dependable, localized objects. Even when John Dalton revived the theory in the early 1800s, he treated atoms like identical indestructible weights. He spent his life measuring the quantities of elements in chemical reactions, noticing that they always combined in perfect whole number ratios. To Dalton, this was the smoking gun. If you needed exactly twice as much oxygen to turn carbon into carbon dioxide as you did for carbon monoxide, it meant oxygen came in discrete units. It came in bits. Dalton even drew them, beautiful, perfect circles that looked like marbles. But as the 20th century arrived, our species finally got close enough to the grain of sand to actually look at it. And what we found didn't just break the marble, it shattered our entire concept of what it means for something to exist. The first thing to go was the solidity. If you look at your own body or the screen you're holding, you see matter. But modern physics tells us that 99.99999999999% of an atom's volume is just empty space. This is a number so large that our brains simply cannot process it. To bring it down to earth, think back to that grain of rice. If you were to take the Empire State Building and subtract every bit of empty space from between the nuclei of its atoms, the entire massive skyscraper would collapse into the size of a single grain of rice. It would still weigh millions of tons, but it would be a tiny speck. If you did the same to every single human being on the planet, all 8 billion of us, the entire human race would fit inside the volume of a single sugar cube. We are, quite literally, ghosts made of nothing. This leads us to the heart of the delusion. If the atom is almost entirely empty, then why is the world so hard? Why doesn't your hand fall through the table? Why doesn't the earth beneath your feet give way? We used to think it was because the marbles were packed tight, but we now know the truth is much more haunting. What you perceive as solid is actually the result of electromagnetic repulsion. You are feeling the no trespassing signs of quantum fields. When you sit in a chair, you are levitating a fraction of a millimeter above its surface, held up by the frantic resistance of invisible forces. The solid world is a tactile illusion created by the interaction of voids. But here is the deep lore that the textbooks and the popular videos rarely tell you. When we say an atom is empty, we are using a word that doesn't actually exist in the universe. In our everyday lives, we think of a void as a place where there is nothing. But in the atomic realm, nothing is a boiling, violent sea. This is the reality of quantum fluctuations. Even if you could go to a point in space where there are no atoms, no light, and no heat, a perfect vacuum, it would still not be empty. It would be a space filled with fields that have potential energy, building and dissolving spontaneously. At the smallest scales, particles are popping in and out of existence in the blink of a trillionth of a second. They are virtual particles, like the C quarks that make up 99% of a proton's mass. Think about that for a second. We used to think the proton was a solid thing in the middle of the atom. Now we know that the 3 real quarks inside a proton only account for 1% of its mass. The other 99% comes from an infinity of gluons and virtual quarks that don't even exist in the traditional sense. They are flickering shadows, appearing and disappearing so fast they don't break the laws of physics, but staying just long enough to give you the weight you feel when you step on a scale. Your weight, your mass, your very presence in this room is almost entirely derived from stuff that isn't actually there. You are a localized peak in a boiling ocean of probability. The Democritus delusion was the belief that if we just looked deep enough, we would find the bottom of reality, the final, solid, uncuttable unit. But what we found instead was a trap door. We looked for the marble, and we found a void. We looked for the void, and we found a field. We looked for the field, and we found that it stretches across the entire cosmos. This is why the atom is so strange. It's not just small, it's a category error. We are trying to use the language of things to describe something that is a process. We are trying to use the logic of the billiard ball to describe a flicker in a high-dimensional ocean. The uncuttable unit turned out to be a hallucination of the human scale. And yet, this hallucination is remarkably stable. It is so stable that it took 13.8 billion years of cosmic history, from the first protons forming in the heart of the Big Bang to the first atoms recombining 380,000 years later, to create the world you see. It is a structure so finely tuned that if you change the mass of a quark by a fraction of a percent, the entire boiling sea would evaporate and the bricks of the universe would simply cease to be. We are standing on a bridge built of ghosts, looking down into a vacuum that is alive with energy. We have spent thousands of years trying to find what the world is made of, only to realize that the more we look, the less there is to see. The atom isn't the stuff of the universe. It is the pattern the universe makes when it tries to look like stuff. The quest for the indestructible unit has ended in the realization that nothing is indestructible because nothing is truly solid. We are ripples in a field, dreaming of marbles. And as we move into the next chapter of this mystery, we have to ask, if the atom isn't a solid thing in our space, then where and what does it actually inhabit? We have spent our entire lives believing that the universe is a three-dimensional room. It's a very comfortable room. It has a floor, a ceiling, and walls. Everything you have ever loved, every mountain you've climbed, and every star you've gazed at fits perfectly within these three coordinates: length, width, and height. Because our brains evolved to survive in this specific 3D environment, we naturally assume that the building blocks of reality must also live here. We imagine the atom as a tiny object sitting inside our space, like a marble sitting in a box. But this is where the mystery stops being a matter of scale and starts becoming a matter of dimensions. This is the 3D prison. To understand why your 3D intuition is lying to you, we have to look at the math that actually describes a multi-electron atom. In the previous chapters, we talked about the cloud of the electron, the orbital. When you look at a picture of a single hydrogen atom with its lone electron, the 3D cloud looks like a real thing. It fits in our world. You can point to it. But the moment you add a second electron, the moment you move from hydrogen to helium, the 3D map of reality begins to tear at the seams. In classical physics, if you have two marbles in a box, you just need 3 coordinates for each marble to know where they are. Marble A is at XYZ and marble B is at XYZ. They are 2 separate things in one 3D space. But atoms don't work like marbles. Because of quantum entanglement and the way wave functions interact, you cannot describe 2 electrons as 2 separate 3D clouds. To the universe, they are not 2 things. They are one single, combined system. And here is the glitch that almost no one talks about. To describe that one system of 2 electrons, the math requires 6 dimensions. 3 for the first electron and 3 for the second, all woven into a single, inseparable mathematical fabric. If you have an atom of oxygen with 8 electrons, that atom doesn't exist in 3 dimensions at all. It lives in a 24-dimensional realm. If you look at an atom of gold with its 79 electrons, you are looking at a structure that inhabits a 237-dimensional space. This is called configuration space, and it is arguably the most obscure and radical lore gap in our understanding of the atom. We often see beautiful rainbow-colored donuts and complex blobby shapes representing atomic orbitals. We are told these are what atoms look like. But these visuals are actually a desperate translation. They are a way of taking a high-dimensional mathematical ghost and forcing it to project a shadow onto our low-dimensional 3D wall. Think about a 3D sphere passing through a 2D plane inhabited by flat, 2-dimensional beings. The flatlanders would only see a circle that appears out of nowhere, grows in size, and then shrinks and vanishes. They would argue about what this circle is, never realizing it is just a tiny distorted slice of a much larger 3D object they can't even conceive of. We are the Flatlanders. Our 3D world is the 2D plane, and the atom is the high-dimensional sphere passing through it. What we call an orbital or a probability cloud is just the 3D footprint of a 30-dimensional or 100-dimensional structure. The atom isn't inside our space. Our space is just a low-resolution interface where we see a tiny fraction of what the atom actually is. This changes everything. If the fundamental units of your body don't actually live in 3 dimensions, then you don't actually live in 3 dimensions. Your solid 3D existence is a projection, a holographic summary of a much more complex, high-dimensional reality that is happening behind the curtain. The 3D prison is the biological limit of our own minds. We want to see the nitty-gritty reality of atoms. We want a good picture that makes sense to us. But the deeper we go, the more the universe seems to be telling us that our sense is the problem. The reason we find quantum mechanics so strange and counterintuitive isn't because the universe is broken. It's because we are trying to fit an ocean of information into a thimble of perception. Consider the uncertainty principle. We are taught that you can't know both the position and the momentum of an electron at the same time. We treat this like a measurement problem, as if the electron is hiding its data from us. But in the context of configuration space, the mystery starts to clear up. The uncertainty isn't a lack of information, it's a perspective error. When we try to measure an electron in 3D space, we are trying to pin down a single point on a high-dimensional wave. It's like trying to define the location of a song while it's playing. The song doesn't have a single x, y, z coordinate. It is a pattern that exists across time and frequency. When we force the atom to appear in our 3D world, when we observe it, we are essentially taking a geometric slice of a larger, deterministic system. This is what physicists call the collapse of the wave function. But some fringe theories suggest that the wave function never actually collapses. Instead, we are just seeing one particular 3D frame of a high-dimensional movie that is playing out in its entirety, all at once, in a space we can't see. This is why the solar system model is so damaging. It doesn't just get the shapes wrong, it gets the arena wrong. It makes us think the atom is playing by our rules, in our house. But the atom is a guest from a much larger house. It is a mathematical object that only looks like a particle or a wave because those are the only 2 costumes our 3D world allows it to wear. As you sit there reading these words, billions of high-dimensional events are happening inside every cell of your eye. Each carbon atom, each nitrogen atom is a flickering, vibrating inhabitant of a multi-dimensional realm, momentarily casting its shadow into the 3D void so that you can perceive a solid world. We are walking, talking, thinking collections of high-dimensional ghosts. The 3D prison is a comfortable place to live, but it is a shallow place to seek the truth. To truly understand what an atom is, we have to stop looking at the clouds and start wondering about the sky they are floating in. We have to accept that the reality we touch and feel is just the surface of a deep mathematical ocean. But if the atom is a high-dimensional structure, how does it move? How does it get from point A to point B? If we can't trust our eyes to see the dimensions it lives in, can we trust them to see its motion? Because as we're about to see in the next chapter, the way an atom moves is perhaps the most unsettling secret of all. It doesn't just inhabit a different space, it follows a different set of rules for existence itself, rules that suggest the world isn't just a projection, but a flickering, jumping illusion. Imagine you are standing at the edge of a perfectly still, moonlit lake. The surface is like a dark mirror showing you nothing but the reflection of the stars above. Now imagine you take a single grain of dust and drop it into the center. You watch it sink, but as it descends, you realize something strange. You can't actually see the dust itself. You only see the ripples it creates on the surface. You see the way the water bends and undulates, the way the light catches the moving crests. You see the influence of the dust, but the dust itself remains a ghost, hidden somewhere within the medium. This brings us to the most frustrating question in the history of science. What does an atom actually look like? If you look at the standard depictions, you're usually met with two extremes. On one hand, you have the friendly cartoon diagrams, the little grapes and solar systems we've already dismantled. On the other hand, you have the more technically accurate versions, the fuzzy clouds, the balloon-like lobes, and those bizarre rainbow-colored donuts. But even these don't quite satisfy the itch. We look at a blobby thing and we have to ask, what does this have to do with an orbiting particle? Is the electron inside the blob? Is it the blob itself? Why are some of them shaped like donuts while others look like dumbbells? And why, for the love of physics, are the donuts rainbow-colored? We want a picture that actually has something to do with the nitty-gritty reality of atoms, because atoms are real things. We want a map that represents the territory, much like a diagram of the solar system, even if not to scale, conveys the real idea of planets orbiting a central sun. But the wave-particle nature of quantum mechanics means our everyday intuition simply doesn't translate. Our brains are built for a world of stuff, but the atom is built of states. To bridge this gap, we have to use a specific mental framework, a way of thinking about wave-particle duality that turns the abstract math into something we can almost touch. This is the ghost in the water. Picture the wave function of an atom not as a cloud of electron stuff, but as a volume of water. Now, picture the electron itself as a single speck of dust caught in that water. In this model, the dust is mostly guided by where the water goes. The water is guided by the fundamental equations of the universe, the recipes that determine how quantum fluid behaves depending on its environment. When you apply this math to an atomic orbital and render it in 3 dimensions, the result isn't a static cloud. It is a mesmerizing, flowing structure. If you could look at the ground state of a hydrogen atom through this lens, it would look remarkably cute, a small, vibrating sphere of potential. But as you move to the excited states, the majestic nature of the atom reveals itself. You see patterns, you see flow, you see the dots representing all the places that a single electron could be. A higher density of dots means a higher probability of finding the electron there. And most importantly, you see that these are truly orbitals. Something is actually orbiting. The motion of the dots shows the flow of the wave function, and it corresponds to the atom's actual angular momentum. But here is where we hit the philosophical wall. We have this beautiful image of the water and the dust, but we have to ask the most unsettling question in quantum physics. Is the water real? This is the great schism of modern science, a divide that separates the world's most brilliant minds into 2 warring camps. It is the debate between the psi-ontic view and the psi-epistemic view. It sounds like academic jargon, but it is actually a battle over the very definition of existence. In the psi-ontic corner, we have the realists. They believe the wave function, the water, is a physical, tangible part of reality. In this view, the electron isn't just a particle hiding in the fog. The electron is the spread-out mathematical object. The water is the primary reality, and the dust is just a localized peak in that field. If you are a psi-ontic believer, you accept that the universe is made of waves of probability that are as real as the chair you're sitting on. The rainbow donuts aren't just pretty pictures. The colors represent the phase of the wave function, which determines how different atoms interfere with each other. The phase is a physical property, a real timing of the cosmic vibration. But then you have the psi-epistemic corner. These are the informationists. They argue that the wave function isn't a thing at all. Instead, it is a map of our own ignorance. To them, the water isn't real. It's just a recipe, a ledger of what we know about where the electron might be. Think of a weather map showing a 70% chance of rain over London. There aren't giant translucent 70% signs floating in the sky. The percentage exists in our heads and on our screens. It's a tool for prediction, not a physical object. The epistemic view suggests that there is a real electron with a real position, and the wave function is just the best guess our limited perspective can offer. This creates a staggering paradox. We can calculate everything about atoms with near-perfect precision. We can build lasers, transistors, and MRI machines using these equations. And yet, we cannot agree on what they actually are. We are like master chefs who have the perfect recipe for a cake, but we have no idea if the ingredients actually exist, or if the cake is just a collective hallucination. If the water is real, then we have to accept the ghost in the water as a literal description of our world. We have to accept that we live in a fog of possibility. This fog is what our intrepid automonauts would find if they tried to land on an electron. They wouldn't find a solid surface. They would just float into a blur where the electron simultaneously occupies every possible spot around the nucleus. One single electron envelops the nucleus like a mist, and it only becomes a particle when something, a photon, a measurement, a conscious observer, forces the universe to provide an answer. But let's look closer at that mist. Even if the wave function is real, it behaves in ways that defy every rule of thingness we know. Take the property of spin. We're taught that electrons spin like little tops. But the math tells us that's impossible. An electron is a spin-half entity. To understand how weird that is, think about yourself. If you spin around in a full 360-degree circle, you end up back where you started. You are a spin-one entity. But an electron? An electron has to be rotated 720 degrees, 2 full circles, to return to its original state. Physicists say it's useful to think of them as spinning, but they aren't actually rotating balls of charge. They are point particles with no internal structure, yet they have magnetic properties as if they were spinning. It is a giant hall of mirrors. Deception, illusion, and subterfuge accompany every attempt to understand it. The ghost in the water analogy helps us visualize the flow, but it also reveals the terrifying scale of our own disconnect. We see dots and clouds because that is the visual language our brains can understand, the language of objects and light and shadows in 3D space. But the nitty-gritty reality is that we are trying to use the vocabulary of the macroscopic world to describe a realm that doesn't use those words. This brings us back to the Kurzgesagt observation. The probability of an electron being in one spot never truly hits zero. The water of the wave function stretches out, thinner and thinner, but it never stops. If the wave function is on tick, if it is a real thing, then every atom in your body is physically, mathematically connected to the furthest reaches of the observable universe. Your ghostly water is overlapping with the ghostly water of a star 10 billion light-years away. This isn't just poetry, it's a potential literal description of the cosmos. If the wave function is the real atom, then individual atoms might be an illusion. We think of them as separate because we see them as separate dots, but if the water is real, then there is only one ocean. There is only the universal wave function, and atoms are just the specific majestic patterns that emerge when that ocean ripples in a certain way. We stand at the edge of this mystery, looking at the mesmerizing, beautiful visuals of these orbitals. We see the cute hydrogen atom and the majestic, excited states, and we realize that the lie of the marble has been replaced by something much more profound. The atom isn't a billiard ball, and it isn't a solar system. It is a flickering, jumping, high-dimensional ghost trapped in a sea of its own probability. The battle between the realists and the informationists remains unresolved. But whether the wave function is a physical thing or just a map of our ignorance, the result is the same. The world we see is not the world as it is. We are looking at the ripples, and we are catching glimpses of the dust, but the true nature of the water remains the deepest secret of the universe. Because if the water is the recipe for reality, we have to ask, who wrote the recipe? And if the water is just a map of what we don't know, then what is the real electron doing when we aren't looking? As we move deeper into the atomic realm, we find that the ghost in the water isn't just a metaphor for the atom, it's a metaphor for us. We are the observers trying to understand the medium we are made of, and the more we look, the more the water seems to look back. The atom is a question, and as we transition from the flow of the wave function to the jumps of the particle, we are about to find that the answer is far more discontinuous and far more haunting than we ever imagined. For a moment, I want you to forget about your skin. We usually think of our skin as the ultimate border, the hard line where you end and the rest of the universe begins. Within this border, you are a localized, solid person. Outside of it, you are just a witness to a world that is not you. We spend our entire lives defending this boundary, feeding it, sheltering it, and believing in its absolute reality. But if we take the lessons of the atom seriously, especially the haunting mathematical truth hidden in the wave function, we find that this boundary is a polite fiction. It is a biological hallucination designed to keep you from going insane. If you look at a textbook diagram of an atom, you'll see the orbital, that fuzzy cloud we've been talking about. Scientists often define this cloud as the region where there is a 95% certainty of finding an electron. We draw a circle or a lobe around that 95%, and our brains find peace in that. We think, okay, the electron is in there. We treat that 5% outside the line as a rounding error, a mathematical nuisance that doesn't really matter to the real world. But in the quantum realm, there is no such thing as a rounding error. That 5% is the key to a mystery that stretches from the center of your chest to the furthest, darkest reaches of the cosmic horizon. The math that describes an electron, the wave function, is a curve. As you move away from the nucleus, the density of that curve drops. It falls off quickly at first, then slower and slower. It approaches zero with a desperate intensity, but here is the Kurzgesagt observation that breaks everything. It never actually reaches zero. It never hits the floor. No matter how many millions of miles you travel away from the nucleus, the probability of that electron being there remains a positive, non-zero number. Think about what that actually means for your physical existence. Right now, there is an atom of carbon in your heart. It has 6 electrons. And for every single one of those electrons, the fog of possibility does not stop at your ribs. It doesn't stop at the walls of the room you're sitting in. It doesn't stop at the edge of the Earth's atmosphere. Mathematically, there is a distinct, measurable, non-zero chance that one of the electrons currently making up your heart is actually located on the surface of Mars. There is a chance it is drifting through the rings of Saturn. There is a chance it is being whipped around the event horizon of a supermassive black hole in a galaxy 10 billion light-years away. This is the universe-sized electron. We like to think of atoms as the Lego bricks of the universe, tiny, discrete units that you can pick up and move around. But a Lego brick has a clear edge. You know where it is, and you know where it isn't. An atom is not like that. An atom is more like a sound. If you ring a bell in a giant cathedral, the sound is loudest right next to the bell. That's the 95%. But the vibration travels. It bounces off the walls. It seeps through the cracks. It enters the soil, and it technically vibrates the entire building, however slightly. The atom is the bell, the vibration, and the entire cathedral all at once. You are not a collection of localized dots. You are a localized peak in a field that is as wide as the universe itself. Imagine our intrepid automonauts from the previous chapters. They are drifting in their tiny ship inside a hydrogen atom, surrounded by a fog of possibility. In the simplified models, they expect to find the electron somewhere near the proton. But as they venture further out into the void, the fog never truly thins into nothingness. They could sail for 1 trillion years, crossing the vast gulfs between galaxies, and they would still be inside the cloud of that original hydrogen atom. They would still be in the territory of a single particle. This realization destroys the concept of here and there. If every atom in your body is technically everywhere at once, then the very idea of a separate object starts to dissolve. This is why some of the most radical thinkers in physics suggest that individual atoms are actually an illusion. We perceive them as separate because our 3D prism only allows us to see the peaks of the waves, the parts where the probability is highest. We see the dots of the minute physics visuals and we think, there it is. But the dots are just the places where the wave function is loudest. The silence between the dots isn't actually silent, it's just a whisper we aren't equipped to hear. This creates a physical and mathematical connection between you and the furthest reaches of the cosmos that is far more intimate than just stardust. You've heard the saying that we are made of the remnants of dead stars, that the carbon in your bones was forged in a supernova billions of years ago. That's a beautiful story about history and heritage. But the universe-sized electron is a story about the present moment. It means that right now you are entangled with the sky. Your physical structure is not a closed system. You are a cosmic interference pattern. Every time a distant star flickers, every time a galaxy collides, the water of the universal wave function ripples, and because your electrons are part of that same water, you are, in the most literal mathematical sense, part of that event. You aren't just in the universe, you are a localized expression of the entire thing. This is the perspective shift that most documentaries are afraid to take. They want to keep the atom small because small is manageable. If the atom is small, then we are big and we are in control. But if the atom is universe-sized, then our size is just a matter of where we choose to draw the line. We have chosen to draw the line at our skin because it's useful for hunting and gathering and navigating a 3D world. But the universe doesn't care about our utility. The universe doesn't recognize the border of your skin. If we could see reality as it truly is, if we could see the full fog of possibility without the 95% filter, we wouldn't see a world of separate objects. We would see a single, shimmering, infinite web of probability. We would see that you are a place where the universe is thinking particularly hard about being a human being, but that you also extend out to the stars. The universe-sized electron tells us that the emptiness between the stars is not empty at all. It is filled with the overlapping tails of every atom that has ever existed. The void is a crowded place, thick with the mathematical ghosts of everything from the beginning of time. When you look up at the night sky, you aren't looking at distant, isolated fireballs. You're looking at objects that are physically overlapping with your own heart. You are looking at peaks in a field that you are currently standing in. The light from those stars is just one way that field communicates with itself. This brings us back to the investigator narrative. Why did the universe choose to be this way? Why build a reality where things are mostly in one place, but technically everywhere? Some suggest it's a form of cosmic backup, that the fine-tuning of the universe requires this total, absolute connectivity to maintain stability. Others suggest it's a hint at a holographic reality, where every part contains the information of the whole. But for you, the individual, the meaning is more personal. It means that you can never truly be isolated. You can never be lost in the void because you are the void. You can never be separated from the cosmos because the cosmos is the very stuff your individual atoms are made of. The lie of the marble told us we were small, solid, and alone. The universe-sized electron tells us we are vast, ghostly, and infinite. We have spent thousands of years trying to find the bottom of the atom, only to find that the atom has no bottom and no edge. It is a structure that begins in the heart of a proton and ends only at the boundary of existence itself. As we transition from this cosmic scale back down to the flickering, jumping reality of the particle, we have to carry this sense of vastness with us. We have to remember that the small world we are about to explore is just the tip of an infinite iceberg. Because if an electron can be on the other side of the universe, we have to ask, how does it get there? Does it travel? Does it flow like water? Or does it do something much more terrifying? The answer lies in the jumps, the moments where the fog of possibility snaps into a single, sharp reality. And as we'll see in the next chapter, the way the atom chooses where to be is the final glitch that proves we are living in a reality that is far more strange than we ever dared to imagine. We have arrived at the most haunting crime scene in the history of science. Our investigators, the physicists of the 20th century, had spent decades chasing a ghost they called the atom. They had mapped its influence, calculated its mass, and even caught glimpses of its fog of possibility. But every time they tried to pin it down, every time they tried to ask, "Where are you right now?" the universe seemed to commit a desperate act of subterfuge. They encountered what we now call the measurement problem. And the solution to that problem doesn't just change how we see the atom, it shatters the idea that we live in a single, solitary reality. To understand the mystery, you have to put yourself in the shoes of an investigator looking through a quantum microscope. In our previous chapters, we saw that an electron isn't a point, but a spread-out wave, the water in our lake. But here is the glitch. The moment you look at it, the water vanishes, and a single speck of dust appears. It's as if the universe is a shy performer that only acts like a wave when the lights are off, but snaps into a solid particle the moment the audience takes a seat. For nearly 100 years, the official Copenhagen explanation, led by thinkers like Niels Bohr, was that the act of measurement causes the wave function to collapse. They told us that the fog simply disappears, leaving behind one single, random reality. But for a young investigator named Hugh Everett III, sitting in a room in 1957, this explanation felt like a desperate cover-up. He realized that the collapse wasn't found anywhere in the math. The equations that describe the atom, the ones that work with perfect precision, don't show a collapse. They show a continuous, beautiful, and eternal flow of waves. Everett asked the question that would change everything. What if the wave function never collapses? What if the fog doesn't disappear when you look at it, but instead you simply become part of the fog? This is the birth of the many worlds interpretation, and it transforms the atom from a thing into a branching tree of infinite possibilities. In this view, measurement isn't a destructive act that kills off possibilities. It is a geometric slice of a larger deterministic system. Imagine our automonauts drifting in that hydrogen atom again. They see the electron as a blur, occupying every possible spot around the nucleus simultaneously. In the old story, when they measure the electron, the universe rolls a pair of cosmic dice and picks one spot for them to see. But in Everett's world, the universe doesn't choose. Instead, the universe splits. Every time an atom interacts with anything, a photon of light, a magnetic field, or the eye of an observer, it generates multiple universes. In one branch of reality, the automonauts see the electron at point A. In another branch, exactly as real as the first, they see it at point B. In a third, it's at point C. There is no choice. There is only a relentless, infinite branching of reality where every possible state of the atom exists simultaneously in its own separate universe. Our investigators realized that this solves the measurement problem by removing the need for a glitch. The math stays pure. The water of the wave function doesn't have to vanish. It just flows into different rivers. But the price of this mathematical purity is staggering. It means that we live in an infinite thicket of branching realities. It means that you are not a single person living a single life. You are a localized peak in a universal wave function that is branching trillions of times every single second, driven by the microscopic choices of every atom in your body. Think about the scale of this reality collapse. We've talked about how an atom is 99.9% empty space and how its probability never truly hits zero. Now combine that with many worlds. It suggests that the atom is not just a fragment of matter, it is a gateway to a multiverse. Every atomic interaction in your heart, every collision of particles in the sun, every vibration of a distant star is a moment of cosmic bifurcation. The atom doesn't just exist as a probability, it exists as an infinite series of actualities. The investigator narrative here takes us to a dark and lonely place for the individual scientist. For decades, Everett's idea was dismissed as science fiction or mathematical vanity. But as our technology improved, we began to see the fingerprints of these other branches. We found entanglement, the way two atoms can remain connected across vast distances, as if they are part of the same high-dimensional structure. This is only possible if they share a single wave function. And if they share a wave function and that wave function never collapses, then the many worlds conclusion becomes almost impossible to avoid. The atom is the splitting point of the cosmos. We see it as a building block because we are trapped in one specific branch of the thicket. We are like travelers on a single path through a dense forest, convinced that our path is the only one that exists. But the atom is the evidence that the forest is infinitely deep. It is the proof that reality is not a thing that happened once, but a process that is happening everywhere, all the time, in every possible way. This brings us back to the universal wave function, the idea that individual atoms do not truly exist. If the many worlds interpretation is correct, then there is only one wave function for the entire universe. Atoms are just patterns within this structure, like ripples in a pool. But because we are also made of those same ripples, we are entangled with the patterns we see. When you look at an atom, you aren't an outside observer looking in. You are a ripple interacting with another ripple, and the result of that interaction is that both ripples split into new versions of themselves. We are not just made of atoms, we are made of the jumps between worlds. The strangeness of the atom is actually the strangeness of our own perspective. We feel solid and singular because we can only perceive one branch at a time. But the nitty-gritty reality of the atom reveals that we are ghostly inhabitants of a much larger, much more terrifying structure. The many worlds interpretation turns the atom into a question that has every possible answer at once. It suggests that the 3D prison we discussed earlier isn't just a spatial limit, it's a reality limit. We are only seeing one geometric slice of a deterministic, high-dimensional movie. Behind the curtain of our perception, the atom is performing every dance, taking every path, and occupying every state, forever. As our investigators close the file on Chapter 6, the mystery has only deepened. We started by looking for a marble, and we found a wave. We looked for the wave, and we found an infinite thicket of universes. The atom is the point where our world stops being a single story and starts being an infinite library. And as we move into the next chapter, we have to ask, if the atom is branching the universe into infinite realities, then how does it stay so stable? How does the flickering and the jumping create the solid world we see? Because the final secret of the atom isn't just about where it lives or how it splits. It's about the random discontinuous motion, the flickering strobe light of existence that creates the illusion of matter from pure, localized chaos. We have seen the water, we have seen the ghosts, and we have seen the worlds. Now we must see the flicker. We have spent a long time trying to visualize the atom as something that flows. We've looked at the water of the wave function and the majestic patterns of the orbitals, watching as the dots in our models drift in beautiful rhythmic currents. It's a comforting image. It suggests that even if the atom is a ghost, it is a ghost that follows a path. It suggests that the electron, whatever it truly is, has a sense of going somewhere. We like the idea of flow because flow implies continuity. It implies that to get from point A to point B, the universe has to pass through everything in between. But as we peel back the final layers of this hole of mirrors, we find a theory that suggests even the flow is a lie. We find ourselves staring into the frantic, stuttering heart of a reality that doesn't move. It flickers. This is the fringe territory of random discontinuous motion. It is the idea that the cloud we see in our textbooks isn't a spread-out object at all, but a frantic, localized sequence of teleports. To understand this, I want you to imagine you are standing in a pitch-black room. In the center of that room is a dancer. If the dancer moves normally and you turn on a continuous light, you see her glide across the floor. You see her path. You see the flow. This is the Bohr model. This is the solar system analogy that we learn as children. Now imagine we turn off that continuous light and replace it with a high-frequency strobe. If the strobe is fast enough, flashing thousands of times a second, your brain will still perceive a smooth motion. You'll think she's gliding. But if we slow the strobe down, or if the dancer starts moving in a way that defies physics, the illusion breaks. You see her here, then poof, she is there. There was no movement between the 2 points. She didn't travel the distance. She simply ceased to exist at point A and spontaneously manifested at point B. According to the theory of random discontinuous motion, this is exactly what an electron is doing every moment of every day. We've been told that the electron is a cloud of probability, a fog of possibility that envelops the nucleus. We've been told that it occupies every spot at once until we look at it. But this fringe interpretation suggests something much more unsettling. It suggests the particle is real, and it is always a single point, but it has no trajectory. It is jumping randomly between positions, guided by the probabilities of the wave function. It exists in one spot for a trillionth of a second, and then it vanishes, only to reappear somewhere else within the cloud. It is a strobe light reality. And because it happens so fast, completing quadrillions of jumps every second, it creates the perfect illusion of a solid, spread-out structure. Think about the implications of this for a moment. If this is true, then the solid objects you touch are not actually solid in any way we understand. They are the result of a frantic, localized chaos. Your hand isn't a collection of building blocks. It is a collection of flickering points that are popping in and out of existence with such violent frequency that they paint the image of a hand onto the canvas of the universe. This is the subterfuge and deception that accompanies every attempt to understand the quantum world. We look at a scanning tunneling microscope image and we see what looks like a row of hills, the silicon atoms. We think we are feeling a surface, but we are actually feeling the resistance of a field that is being generated by particles that are never actually there for more than an instant. We are feeling the average of 1,000 trillion teleports. Our automonauts, drifting in their ship inside the hydrogen atom, wouldn't find a fog if they had eyes that could see fast enough. They would see a single, blindingly fast speck of light that appeared to be in 1,000 places at once. They would see a reality that is fundamentally discontinuous. This solves one of the biggest headaches in physics, the transition from the wave to the particle. In the standard view, we struggle to understand how a spread-out wave suddenly collapses into a point. But if the particle is always jumping, then the wave was never a physical thing to begin with. The wave function was just the rhythm of the jumps. It was the statistical map of where the strobe light was most likely to flash. The water in our ghost in the water analogy isn't an ocean the electron swims in. The water is the pattern of where the ghost chooses to haunt. And this flickering isn't just limited to the electrons. When we look at the nucleus, at the protons and neutrons, the weirdness only intensifies. We've discovered that 99% of a proton's mass comes from virtual particles, sea quarks and gluons that pop in and out of existence for just a sliver of a second. They don't exist in the traditional sense, yet they provide the weight of everything you see. The entire universe, from the atoms in your eyes to the stars in the Sloan Digital Sky Survey, is built on the back of things that are barely there. We are living in a slideshow that is playing so fast we think it's a movie. We are virtual beings made of virtual mass, held together by the flickering jumps of high-dimensional ghosts. This is why the atom is so strange. It defies our most basic intuition about motion. We believe that for a thing to move, it must exist at every point along its path. But the atom says, no, I can be here, and then I can be there, and the space between doesn't matter. It is a reality of randomness that somehow produces order. Think about the fine-tuning we discussed. The universe is a giant control panel where the dials are set with impossible precision. If the electromagnetic force were slightly different, or if the strong force were 9% weaker, this flickering dance would fall apart. The strobe light would stop. The particles would either fly off into the void or crash into the nucleus, and the illusion of matter would evaporate instantly. We are the beneficiaries of a cosmic strobe light that never misses a beat. We are the result of a random motion that is so perfectly tuned that it allows for chemistry, for biology, and for consciousness. But this leads us to the most haunting realization of all. If the atom is a flickering jumping point, if it is a strobe light in the dark, then what happens in the gaps? What is the electron doing in the trillionth of a second when it has vanished from point A but hasn't yet appeared at point B? Where does it go? Some suggest it retreats back into that high-dimensional configuration space we talked about. Others suggest it is branching into another world of the many worlds thicket. But the fringe theory of random discontinuous motion suggests something even more radical. It doesn't go anywhere. In those gaps, it simply isn't. Reality, at its most fundamental level, is not a continuous stream. It is a series of events. It is a sequence of is and is not. The universe is constantly blinking. And because we are made of that same blinking matter, we blink with it. We don't notice the gaps for the same reason you don't notice the black space between the frames of a movie, because your perception is part of the film. The solid world you're touching right now is a grand illusion sustained by the sheer speed of this quantum stutter. The emptiness that makes up 99.9% of the atom isn't just space. It is the waiting room for a particle that is currently manifesting somewhere else. We have spent thousands of years trying to find the indestructible unit of matter. We wanted to find the marble that would stay still so we could look at it. But we found that the unit of reality isn't a thing at all. It is an occurrence. It is a flicker. The atom is not a building block. It is a strobe flash in a 168-dimensional dark room. It is a jump in an infinite ocean of probability. And the strangeness we feel when we look at it is the feeling of our own 3D brains trying to make sense of a reality that isn't just not what it seems, but not even when it seems. We are ripples in a field, dreaming of marbles, but those ripples are made of poofs and flashes. We are the ghosts in the machine, and the machine is made of ghosts. As we move toward the final mysteries of the atom, toward the idea that individual things might not exist at all, we have to hold on to this image of the strobe light. Because if the world is a flicker, then the most important question isn't what is an atom, but what is the light that is doing the flashing? The universe-sized electron told us we are vast. The many worlds told us we are infinite. But the flickering reality tells us we are, in every meaningful sense, a beautiful high-frequency hallucination. We are a glitch that has been tuned to look like a world. And once you see the flicker, you can never go back to the marble. You realize that you have never touched a thing in your life. You have only ever participated in a dance of localized randomness, a cosmic jump that has been repeating for 13.8 billion years without ever stopping to explain why. The atom is the strobe light, and we are the dancers caught in the flash, forever appearing and disappearing in the dark. Think about the word part. You've spent your whole life using it. You think your car has parts, your phone has parts, and your body has parts. We have been taught that the universe is a giant machine, and to understand it, all you have to do is take it apart until you find the smallest, most fundamental bit. We call that bit the atom. We've called it the building block and the Lego brick of reality for so long that we've forgotten it's just a metaphor. But as we stand at this stage of our journey, we have to face a truth that is much more radical. There are no parts. There is no stuff. There is only a single infinite event happening all at once, and you are just a specific rhythm within it. This is the end of things. To understand how we lost the thing, we have to look at a phenomenon called entanglement. In the earlier chapters, we talked about the atom as if it were a lonely ghost, a localized peak in a field. But in the real world, atoms are never lonely. They are constantly bumping into each other, exchanging photons, and feeling each other's fields. In the standard Copenhagen view of physics, these are just interactions between separate objects. But the math tells a different story. When two quantum systems interact, their wave functions, the water we've been imagining, don't just bounce off each other. They merge. They become entangled. At that moment, the two atoms cease to exist as individual entities. You can no longer describe atom A and atom B separately. You can only describe the new combined system of AB. Now follow that logic to its ultimate conclusion. If two atoms become one system when they touch, what happens when you realize that every atom in the universe was once touched by every other atom? At the moment of the Big Bang, everything that currently exists, every electron in your brain, every quark in a distant nebula, was compressed into a single infinitesimal point. For a sliver of a second, the entire universe was a single quantum state. And because the equations of quantum mechanics are continuous, that entanglement never went away. It just got more complex. This leads us to the universal wave function. Some of the most profound thinkers in physics suggest that the fog of possibility doesn't just belong to one electron or one atom. There is only one wave function in existence, and it describes the entire universe. In this view, the individual atom is a total illusion created by our limited perspective. We see an atom of carbon or a grain of gold, and we say, there is a thing. But what we are actually seeing is just a localized ripple in a single universal ocean. Think about a wave in the sea. You can point at it, you can track its height and its speed. You can even give it a name. But is the wave a part of the ocean? Can you take the wave out of the water and put it in a box? Of course not. The wave isn't made of water as a separate object. The wave is just something the water is doing in that specific spot. In the same way, atoms are not made of matter. Atoms are just something the universal wave function is doing right here. This is why we say that atoms are the patterns, not the stuff. If you look at your hand, you see a solid object. But we know it's 99.9% empty space. We know the solid feeling is just the repulsion of fields. And now we know that those fields are all interconnected in a high-dimensional configuration space that our 3D brains can't even visualize. You aren't a collection of parts called atoms. You are a specific vibration in a single, infinite field that stretches from the beginning of time to the edge of the cosmos. The investigator narrative of the 20th century was a search for the bottom floor of reality. We wanted to find the marbles so we could feel secure in our thingness. But the deeper we went, the more the floor turned into a liquid, and the liquid turned into a ghost, and the ghost turned into a single, unified vibration. The tragedy of the Lego brick analogy is that it makes us feel separate. It makes us feel like we are islands in a void. But if the universal wave function is real, then separation is the greatest deception of all. Every time you breathe, you aren't just moving air atoms into your body. You are participating in a massive universal interference pattern. The electrons in the oxygen you inhale are already mathematically entangled with the stars you see at night. We aren't just connected to the universe, we are the universe experiencing itself through a localized peak in its own wave function. This is the reality collapse we promised. If there are no individual atoms, then there is no you and not you. There is only the field. We use the word atom as a shorthand, a way to make the infinite complexity of the universal wave function manageable for our daily lives. It's a useful lie. It helps us build technology and medicine, but we must never mistake the shorthand for the reality. When you look at the mesmerizing visuals of an orbital, the cute hydrogen sphere, or the majestic excited states, you are looking at a localized song being played by the universe. The dots aren't separate electrons, they are the pattern of the song. And the most incredible part of this mystery is that the song is finely tuned. If the notes, the strengths of the fundamental forces, were shifted by even a fraction of a percent, the song would become noise, and the illusion of things would dissolve into a chaotic, formless sea. We exist because the universal wave function has found a stable, beautiful rhythm. We are the melody that emerged from the silence of the Big Bang. To understand the atom is to realize that you have never been alone, and you have never been a part of anything. You are the whole, manifesting as a part for a brief, flickering moment in time. The atom is not a building block, it is a boundary where our language of objects fails and the language of oneness begins. We have spent thousands of years trying to take the world apart, only to find that it was never in pieces to begin with. The end of things is not a dark conclusion. It is the ultimate homecoming. It is the realization that the world isn't made of atoms. The world is what the universal wave function looks like when it's dreaming of being you. Imagine you are standing against a cold stone wall in a quiet courtyard. Your hands are tied behind your back, and a heavy blindfold covers your eyes. Your other senses are heightened to a terrifying degree. You hear the synchronized click of 24 rifles being loaded. You hear the officer give the command. You feel your body brace for the impact that will end your story. Then the roar of the volley fills the air. You wait for the pain, for the darkness, but it never comes. You are still breathing. You are still standing. Every single one of the 24 marksmen, despite being experts at their craft, has missed. This is the analogy proposed by philosopher John Leslie to describe the sheer mathematical impossibility of your existence. To look at an atom and say it is just there is like walking away from that firing squad and saying, well, I guess they just weren't very good shots. It ignores the fact that you owe your life to an incredibly precise and improbable sequence of events. This is the glitch in the control panel. If we look past the high-dimensional ghosts and the flickering strobe lights of the previous chapters, we find ourselves in the ultimate engine room of the cosmos. Imagine a giant control panel littered with thousands of knobs, dials, and switches. Each one is responsible for a fundamental property of existence: the strength of gravity, the speed of light, or the mass of subatomic particles. Since the Big Bang 13.8 billion years ago, these dials have been set. And the nitty-gritty reality is that they appear to be stuck in exactly the right positions to allow atoms, and therefore you, to exist. If you were to walk up to this panel and nudge just one dial, even a fraction of a percent, the solid world around you would not just break, it would evaporate. Let's zoom in on one specific tiny dial, the mass of the down quark. As we've seen, the nucleus of an atom is a frantic playground of up and down quarks. A proton is 2 ups and a down. A neutron is 2 downs and an up. In our universe, the down quark is just a whisker heavier than the up quark by about 1/7 of 1%. This tiny difference is the only reason the neutron is heavier than the proton. It seems like a minor bookkeeping detail of the universe, but it is the tightrope upon which all of reality teeters. If you were to adjust that dial and change the mass of the down quark by just a fraction of a percent, the entire history of the universe would be rewritten in fire. If the down quark were slightly heavier, it would become unstable and decay into an up quark. Suddenly, every neutron in the universe would transform into a proton. The marriage of the proton and neutron, the deuteron, would be annulled. Without the deuteron, the short window of opportunity for fusion after the Big Bang would have slammed shut without producing anything. There would be no helium, there would be no carbon forged in the hearts of stars. You would be left with a universe containing only one type of atom, hydrogen. There would be no oxygen for you to breathe, no iron to carry that oxygen through your veins, and no complex chemistry to allow life to even dream of existing. The control panel is full of these lethal traps. If you made the electromagnetic force just a little bit stronger, electrons would crash down onto the nucleus like satellites dragged back to Earth in a blaze of fire. If you weakened it, they would fly off into the void, rendering the automotes of our internal journey forever homeless. If you ratcheted up the strong nuclear force by just 2%, protons would fuse into diprotons, and all the hydrogen in the stars would vanish instantly, leaving a cold, helium-dominated wasteland. We are living in a universe where every marksman missed. Every dial is set to a smoking gun level of precision. And this leaves us with the 3 most uncomfortable questions in science. The first option is dumb luck. Perhaps the settings just had to be somewhere, and we are the winners of a cosmic lottery with odds of 1 in 65 billion trillion. That is roughly the same chance as someone asking you to pick a single star out of a bag containing every star in the observable universe and you happening to pull out our sun on the first try. To many investigators, these odds are too extreme to accept. It feels less like luck and more like a steady hand on the tiller. This leads to the second option, the multiverse. This theory suggests that our Big Bang was not the only one. Perhaps there is an infinity of bangs, an endless foam of universes where every possible setting on the control panel is tested. In one universe, the down quark is too heavy, and everything is hydrogen. In another, gravity is too strong, and everything collapses into black holes. We find ourselves in this specific universe not because it was designed for us, but because it is the only one where the dials permit a giant lump of atoms, like a human being, to exist and ask the question. We are here because we can be here. But then there is the third option, the simulation or the architect. If you saw a man survive a 24-man firing squad, you wouldn't assume he was lucky, and you wouldn't assume there were infinite courtyards where he died. You would assume the guns were loaded with blanks. You would assume the glitch was intentional. This is the idea that our 3D prison and our high-dimensional ghosts are part of a real-life version of The Sims, created by an advanced civilization or an omnipotent deity who manually set the dials to see what would happen. In this view, the atom isn't a building block of nature. It's a line of code. The subterfuge and deception we find when we look at an electron isn't a mystery of physics. It's a limit of the rendering engine. The fine-tuning is simply the parameters of the experiment. We have spent our journey looking for the truth of the atom, only to find that the atom is a question that points toward the very origin of the universe. Whether it is a stroke of impossible luck, a single leaf in an infinite multiverse, or a carefully calibrated simulation, the result is the same. The atom is a ludicrously unlikely entity. You are a walking, breathing miracle of fine-tuning. Every carbon atom in your DNA is a witness to a glitch that stayed stable for 13.8 billion years. We take the atom for granted because it is everywhere, but the history of the universe tells us it should be nowhere. As we move toward our final conclusion, we have to look at the cosmic microwave background, the unmistakable fingerprint of the first atoms forming 380,000 years after the Big Bang. That light is still here, vibrating in the static of old televisions, a reminder of the moment the maze was opened and the first atoms finally coalesced. It is the echo of the moment the dials were set. The atom is the evidence. And whether that evidence points to a lottery, a forest of worlds, or a control panel in the hands of a creator, it proves that the world is not what it seems. It is a tightrope. It is a flicker. And it is, against all odds, real. We have reached the end of the map. We started this journey with a grain of sand on a Greek beach, and we have traveled through the heart of stars, the branching paths of infinite universes, and the flickering strobe lights of a reality that exists only in the gaps of its own presence. We have dismantled the marble, we have seen the ghost in the water, and we have stood before the impossible control panel of the cosmos. Now, as the dust settles, we have to look at the wreckage of our intuition and ask what remains. What is an atom, really, when you take away the metaphors? The answer is perhaps the most unsettling thing of all. The atom is not a thing that we found. It is a boundary. It is the exact point where human language, human logic, and the very concept of thingness reach their breaking point. To understand the atom is to realize that we aren't just looking at the building blocks of matter. We are looking at the edge of the world we are allowed to know. We are staring at a boundary where the universe stops being a collection of objects and starts being something our brains were never designed to process. For centuries, we treated the atom like a secret that was just waiting to be whispered. We thought if we could just build a better microscope, if we could just feel the silicon atoms or scatter enough light off a nitrogen nucleus, the mystery would dissolve into clarity. But the deeper we went, the more we realized that the mystery isn't a lack of data, it's a lack of category. We are like explorers who set out to find the source of a river, only to find that the river doesn't come from a spring, but from a glitch in the geometry of the Earth itself. This is the synthesis of the mystery structure. Throughout this documentary, we have looked at different versions of the atom: the billiard ball, the solar system, the probability cloud, the high-dimensional pattern, the many worlds branch, and the flickering strobe light. In the past, scientists and educators treated these as models, different ways of drawing the same object. But the deeper lore suggests they aren't just models. They are different costumes that a single, non-human reality wears so that it can appear in our three-dimensional theater. When we call an electron a particle, we are using a word that was invented to describe pebbles and dust. When we call it a wave, we are using a word invented to describe the ocean and sound. But the electron is neither. It is a quantum entity that is fundamentally alien to both descriptions. It is an object that inhabits configuration space, a mathematical realm with hundreds or thousands of dimensions, and it only looks like a particle, or a wave, when we force it to cast a shadow into our 3D prison. Imagine you are looking at a complex revolving sculpture made of wire and mirrors, but you can only see the shadow it casts on a flat white wall. If you look at it from one angle, the shadow looks like a circle. From another, it looks like a square. You could spend your whole life arguing about whether the real object is a circle or a square. You could build elaborate theories about circle-square duality. But the truth is that the object is neither. It is a 3D structure that doesn't fit the language of flatness. The atom is that sculpture, and we are the creatures living on the wall. Our 3D intuition tells us that for something to be real, it must have a location. It must have a path. It must be there. But the atom tells us that there-ness is a luxury of the large. At the foundational level, the universe doesn't care about locations. It cares about information, probability, and entanglement. The nitty-gritty reality of the atom is that it exists as a universal wave function, a single, seamless ocean of potential that only ripples into things because of the way we interact with it. This is the ultimate reality collapse. If everything is entangled, and if the wave function of your heart is technically spread across the entire cosmos, then the parts of the universe are just a convenient hallucination. We are not a collection of atoms. We are a specific, temporary vibration in the same fabric that makes up the stars, the void, and the very first light of recombination. The atom is the pattern, not the stuff. And the stuff itself is just the way our 3D senses interpret a high-dimensional ghost. We have seen how the fine-tuning of the universe keeps this ghost stable. We have seen how the mass of a down quark or the strength of the strong nuclear force acts like a glitch in the control panel, ensuring that the flickering strobe light of reality doesn't stop. But why? Why is the universe so carefully calibrated to produce an entity as strange and impossible as the atom? Whether you believe it's dumb luck, a multiverse, or a simulation, the conclusion is the same. The atom is a boundary between the known and the unknowable. It is the place where physics meets philosophy. When we try to describe what an atom looks like, we are forced to use the visual language of our brains: objects, light, shadows, and motion. We create minute physics-approved cartoons and Kurzgesagt marble analogies because our minds would otherwise slip and fall into the void of pure mathematics. But the real atom doesn't look like anything. It is. It is a probabilistic ghost flickering into existence quadrillions of times a second. It is a high-dimensional structure that we only perceive as a 3D shadow. It is a localized peak in a field that connects you to the furthest galaxy. And it is the most information-dense sentence our species has ever written. All things are made of atoms. As we close our investigation, we are left with a final, haunting thought. We started by looking for the bricks of the world, thinking that by understanding the atom, we would finally understand our own solid reality. But the atom has done the opposite. It has revealed that the solid world we touch is the illusion, and the ghostly world of the quantum is the truth. The resistance you feel when you touch a table is the repulsion of invisible fields. The weight you feel in your bones is the energy of virtual particles that shouldn't even exist. The you that you see in the mirror is a 3D projection of a high-dimensional event that is branching into infinite universes at every moment. We have lived our lives believing in the marble, but we are made of the flicker. We believed in the parts, but we are the whole. The atom is not a thing we found at the bottom of a grain of sand. It is the boundary where we realize that the world is much, much stranger than we are capable of seeing. You are not a separate object in a vast and empty room. You are a localized peak in a cosmic ocean. You are the universe looking at its own high-dimensional shadows, trying to name the light that is doing the casting. And though the language of marbles and bricks has failed us, the mystery that remains is far more beautiful than any solid object could ever be. The atom is the question. And as long as we keep looking, as long as we keep feeling in the dark with our scanning tunneling microscopes and our mathematical equations, we are participating in the most profound dance in existence. We are the ghosts in the machine, trying to understand the machine that is made of ghosts. And in that realization, the boundary of knowledge doesn't feel like a wall anymore. It feels like an invitation. It is an invitation to accept that we are part of something vast, connected, and fundamentally mysterious. The world you touch is a shadow. The atom is the ghost. And you are the miracle that happens when the two meet. This has been the story of what an atom really is, and why it is so strange. The next time you look at your hand, remember the 99.9% of emptiness that is actually a boiling sea of energy. Remember the electrons that are technically on the other side of the universe. And remember that you aren't just standing in the universe. You are the way the universe chooses to vibrate, right here, right now, in this specific, beautiful, and impossible branch of reality. The journey to the heart of the atom has ended. But the mystery of being alive in a world made of ghosts is just beginning.